a whole eye approach. Of course, this is that most anterior portion here that we identified as the cornea. In a living eye, it's actually clear. In a preserved eye, it's somewhat cloudy and somewhat opaque. So this is the corneal portion, or cornea, right here. And if we look at the back side from the posterior view, make sure you can identify the optic nerve as it exits the posterior portion of the eye as it penetrates through the sclera. So we're just going to kind of hold the eye something like this. We'll just quickly make a section. And remove the corneal portion. So on this portion, of course, this is the cornea portion. If we turn it over and then somewhat invert it right here, obviously the opening itself is the pupil, and surrounding the pupil, this pigmented part we identified as the iris. In conjunction with the iris, this is where we find the pupillary muscles. We had two layers of muscles within that pupillary layer, and they can either make the opening get smaller or larger as the case may be. And then the outer band here, these are your ciliary muscles. So the ciliary muscles actually attach to this portion that we identified as the lens. So in reality, that was fortunate, popped right in there. So generally it may or may not come out something like this. And so if you remove the lens, you actually have to pry it away from the ciliary muscles. So those are the muscles that can actually exert or dominate the concavity or the convexity of this, and which allows for focus or focusing on the retinal wall. So the outermost layer here we identified as the sclera. See if we can get this. Very nice. So what do we call this? The vitreous. That's the vitreous humor. It's kind of like oysters or something, I don't know. But that is just beautiful right there. So that tan colored layer that you see here, that is the retinal layer. And if you look really closely, you can see that it all converges to one specific spot. And that spot we identify as the optic disc, or the blind spot. And we said that the blind spot is actually a location where we have the total lack of all photoreceptors, no rods, no cones, or anything. So if an image falls or gets focused on the blind spot, it's as if nothing was even there. And that's why sometimes you pull up to an intersection and you glance over and you see no one or nothing, and you glance again and there might be a motorcycle sitting there and you never noticed it the first time you looked. So the innermost layer right there we identified as the retinal layer. I'm going to grab another because I don't want to destroy that. That is just too pretty to destroy. So if we removed that retinal layer, then we would get to the middle layer called the choroid layer, and that's what you're observing right here. See that shiny bluish to black zone in there? That bluish area, and you can read this in the lab manual, it talks about the existence of something known as the tapetum lucidum. Humans do not have that shiny bluish area, but most other mammals do. Cows, dogs, cats, deer, horses, virtually all other animals, if you shine a light into their eyes, it reflects back at you, and that's a function of the tapetum lucidum of the choroid layer. And then, as we said, the outermost layer is the sclera. Likewise, we can, if we look really closely, should be right there, and there it is. The optic nerve right there is just, so you, with the tunic removed, the retina removed, you can actually see that where all of that, you can hardly remove the actual origin of the optic disc. So make sure that as you work your way through, you can identify the lens, be able to identify the pupil, the iris, pupillary, as well as ciliary muscles, the cornea, vitreous humor. And normally on test day, I just use these sectioned eyes as test resources. So this is, helpful, but this is what you need to be familiar with, because this is the actual test resource that we'll be utilizing in only 2 weeks out. So I have trays, I have